couldn't sleep for 3 nights.
Why?
Just because what I learned was terrifying. How come no one's done a documentary about this stuff? And we started seeing some strange things. This topic can frighten people.
Embarrassingly for me, I met Cory Dobbs without knowing who he was. And I asked him, as I ask everybody, what's something crazy you believe in that most people probably don't share with you? And when he looked me in the eyes and he says, what do you know about Mars? I knew that we had a winner on our hands. Turns out this guy has made a documentary. It's done really well in film festivals, and he signed with Amazon recently to release a documentary about Mars in August. We get to talk with him about everything that he believes and everything that he knows. And it's wild. Like, you know that Matt and I go pretty deep into fringe topics, and I didn't know most of the stuff that he told us about Mars. So if you've ever been curious, have a listen. Welcome to the Austin and Matt podcast.
Ryan,
What's up, dude?
that documentary was unbelievable.
Thanks, man.
I can't believe it. We just finished watching the documentary about Blue Planet Red, all things Mars, and it blew my mind.
Dude, that's awesome.
Yeah, man, I gotta say, I've never felt emotional thinking about Mars before, and there was a moment in there when I actually felt emotional. I couldn't believe you evoked that. That's incredible. It makes me wonder how you feel about Mars.
Well, I think it's good that you made note of that. When I first read Dr. Brandenburg's book, we'll get into it all later, but just after I read his book, I couldn't sleep for 3 nights.
Why?
Just because what I learned was terrifying. So, you know, what do most people know about Mars? It's a red planet. And I think that's where it starts and it ends. And I think I had the same reaction that you guys did. It's just like, after I learned all this stuff, I just felt compelled to do something about it. I asked, okay, how come no one's done a documentary about this stuff? What's going on here? All of the information was already published online, or maybe in a YouTube video here or there, but it's all scattered and fractured. I haven't really encountered like a one-stop shop of where you could put it all together, because I think there's I saw a story, and any one individual piece is interesting to that community or to that community, but if you put it all together, then I think you got something that can resonate with the folks, with just your average Joe. I mean, I'm just an average guy. I'm just, just a dude with a curiosity like you guys, So I just felt compelled to get into it because it was more than just data, more than just microbes,
I heard this analogy one time where if you're walking through the forest and you see a watch on the ground, one of two things is true. Either the universe randomly slammed together a bunch of quartz and glass and aluminum and metal and put it all together and made it tell the exact time that it is today, and that maybe that's probable. Or it was created by something else and it exists in nature. And so when I started seeing the evidence that you had in the documentary around what looks like creation on the planet Mars, very symmetrical things, very, a lot of anomalies that are verified by NASA and all the experts that you had, I kind of had that feeling, that moment of like, is this chance? Is this just, did the universe just smash together a bunch of things on this planet really symmetrically, really it's like the difference of digital data versus analog data. It was really fascinating to just see it all unfold. You had a ton of experts. How did you get in touch with, Avi Loeb from Harvard? You had so many on there. Were they open to kind of doing these interviews? And like, what was it like getting all those guys on board?
I got lucky. I'll say that much. But the other thing going on here is I consider Mars and the story of Mars to essentially be the red-headed stepchild of the disclosure movement. The UFOs are getting all the attention these days, which is just fine. They should, but that's not it. There's more to disclosure, and I think Mars has a lot to offer in that regard. It certainly has more data. There's lots of reporting on UFOs. There's more data with Mars. Unfortunately, for the past doggone near half century, anyone suggesting any type of life or artificiality on Mars has been marginalized.
Laughed
They've just
at.
been, yeah. So these guys who spend their entire careers doing the one thing that they're really good at, okay, whether it be biology or chemistry or plasma physics, they publish papers, they've got all the data to back it up, and there's nobody who can adequately refute what they're publishing in their papers. The opposite of love isn't hate; it's indifference, and just people have just ignored this stuff. And I felt like, as a storyteller, I could help, I could contribute, I could perhaps elevate their material and present it in a way that's a little bit more relatable to, just your average audience. Very few people are going to read a research paper about amino acids and nucleobases. But once you start showing pictures, well, then you got a different potential of changing somebody's mind. So a lot of these folks were eager to talk to me. Finding them was challenging at times, yes, but once I finally got a hold of them, they were like, yeah, you want to come next week? I'm like, hell yeah, okay, let me book a plane ticket. And even the more notable people in the film, Robert Schoch, Avi Loeb. Avi Loeb loves talking to people.
He's great.
I don't think he even cares how small of an outlet you are. He'll just talk to you because he understands that media presence, getting your name out there and getting your work out there and becoming a household name, that does a lot to further his science. So, he was, God, it all happened within a matter of minutes. I emailed him and he got back to me. He's like, sure, I'd love to do it. And then he emailed me back right afterwards. And he first told me that he wasn't able to participate because, Netflix is filming for his series on these microspherals in the ocean. So he said, sorry, I can't do it. But then he emailed me just right back again. This is only like 10 minutes. He's like, oh, wait a second. My publicist says it's okay because it's about Mars, something else entirely. So I'm like, okay, great. Yeah, can we Zoom? So we Zoomed. I just wanted to tell him who I was. It all happened like the same day. So someone like that, he's really eager. Robert Schoch, he was actually really receptive to talk about this. As you guys both know, he's one of the lone voices talking about plasma discharge. So I initially approached him. I wanted to talk about all these strange looking hills, these funny looking hills on Mars, which he was somewhat okay talking about. But what he really wanted to talk about was the plasma discharge stuff that he was talking about and the scarring of the surface. So, I was able to provide him an outlet, and, he was more than happy to show up in the rain with his wife at some random Airbnb that I booked up near where he lived in a room half the size of this one, and we got the shots, we got the sound clips. So, it's a miracle that I was able to find some of these guys because they're getting up there in age.
That's right.
And like you guys were just talking about with folks you've interviewed, it's like, you're not sure how long they're going to be around for. Let's get as much out of them as possible. You meet some interesting characters. So, the universe paved the way for me to do this, and I could not have done it alone. Let me just say right up front that there's a gentleman in England who I encountered early on in this process. He himself was a unique find. His name is Michael Craig, and he has been studying this stuff for the better part of 2 decades. I discovered him through Cliff Dunning's podcast on Earth Ancients, and here was a guy in England talking about anomalies on the surface of Mars, and I'm like, wait, what? So as I was researching more about Mars and trying to put my ideas together about how to make a film out of all this, I basically asked him, hey, I know I'm just some random American guy who just heard you on a podcast, but I'm interested in making a film. Would you like to partner with me? And he did. And so he's quite a reserved guy. He doesn't seek the spotlight whatsoever, but boy, does he know his stuff. And he steered me clear. There's a lot of baggage with Mars. And there's a lot of nonsense, a lot of bold claims. And, we've explored this, that, and the other. And he's like, no, we got to distance ourselves from that because it's not vetted. well enough to really put it in the film.
Do you remember any of those? Any of the other things that were not properly vetted that you kind of decided to leave out?
There's talk of secret space programs and things like that. I'm like, I can't go there just yet. Most people don't know this, but Graham Hancock published a book in the late 90s about Mars. And in that book, he draws comparisons to the structures that we see on Mars and relates them to the structures in Egypt. So there's Egyptian comparisons. I didn't want to go there.
Yeah.
It's not something I felt comfortable enough, vetting or really dissecting. But, he also talked a lot about the other stuff, which did make it into the film. So I wanted to try to stick to as much of the nuts and bolts as possible, backed up with the data. Every single image you see in this film, I've sourced it to NASA. I vetted it for myself. Nothing made it in the film unless I could source it back to the original source, which was NASA or European Space Agency. Published papers. This is all material that's been out there. It's just, it needs more visibility.
Well, this brings to mind Carl Sagan. He's been talking, since the dawn of television. I think Carl Sagan was talking about Mars and some of the planets out there. How is it possible we've been talking about this for decades and we don't have the full story yet? How could that even be a possibility? I think that's where a lot of people's minds go. They say, if there was something interesting there, I would know it.
Yes. If we rewind the clock to 1976, when we first got our huge info dump from Mars, okay, the Viking mission provided photographs, both from orbit and from the ground. And it took atmospheric measurements. We learned a lot about Mars, okay? And we started seeing some strange things pretty much immediately in these photographs. And as you saw, we're sort of jumping ahead a little bit here, but Carl Sagan was even questioning some of these surface features. Are they natural or are they not? So even right off the bat, you have notable people such as Carl Sagan, even talking about these features a certain way, suggesting that they're artificial in nature. This topic can frighten people. So, as an institution in charge of, you have to take to give NASA credit, okay, to give anybody credit who's in a position of authority, they don't want mass chaos. And the slightest thing, could flip that switch for people. So, as an institutional authority, I do respect the fact that they have to be very careful with what they say, because speculation can run rampant. But to answer your question, if we do speculate just a little bit, why don't more people know about this? Well, the fact remains that NASA is legally obligated to publish the photos that they take, but they don't need to offer any commentary or analysis. They leave that to the independent researchers. So they can, just keep their hands clean in case there's anything that's strange that ends up in a photograph that gets released to the public. NASA does a fantastic job at collecting data. They just don't really want to talk about their discoveries, whether it be from a photograph or whether it be from a measurement from one of their orbiters or landers. They just simply don't want to talk about it. I've even learned more since the finishing of this film, and so I've been continuing this work on my YouTube channel just because there's even more to the story that did make it in the film because I wasn't even aware of it.
Like new photos or what kind of new stuff?
New photos, new data. Even more, we talked a little bit about the evidence for current microbial life. There's a gentleman by the name of Barry D. Gregorio, who's the long-haired guy on the beach talking about trace fossils. Barry is a wonderful friend, and he is Gil Levin's biographer. Gil Levin was the guy who designed the labeled release experiment that was originally put aboard Viking to go test the soil for microbes. Okay, so Barry wrote the book on Gil Levin and the labeled release experiment, essentially telling the story of microbial life on Mars and how NASA first discovered it in 1976. So Barry was doing this back 30 years ago. But he's been keeping track of this. He's another one of these guys who sifts through images, sifts through the data, knows basically everything there is to know about any type of microbiology on Mars or fossils on Mars. And, Barry kept essentially, I consider him a mentor. I've considered many of these folks a mentor. Michael, my partner, of course. But, Barry outlined for me, a handful of other pieces of evidence for current microbial life on Mars. We can get into it if you'd like, but I am a communicator, okay? I'm not doing the research. I want to find the people who are doing the research and give them the credit that I think they're due. So you've got these guys out there just spending their spare time doing nothing but sifting through the NASA archives, finding stuff and publishing it and trying to get it out the best way they can. And it usually just falls on deaf ears because people aren't paying attention, or they're just so easily dismissed because we don't know who this guy is and he's just making these bold claims. But if you dig into the details, well, hey, you know what? He's not wrong. They're not wrong. And they just simply need a microphone to help tell what the actual story is, and they're the experts.
Yeah, I love the idea of Panspermia. It's a terrible name. Great idea. And we had George Howard on. He was our first episode, and he knows a lot about Mars. And I know you know George, but talking about how they would find microbial life on the outside of different planets. And just the idea also that I think it was mentioned in the documentary that we've tried to create life from non-life so many times. And we've gone in the lab and you throw in a bunch of organic compounds and zap them all or do whatever, and we've never been successful at creating life from non-life. So it's okay to, I think it's compelling to start thinking about other ways that life could emerge, and panspermia being maybe something came from space and crashed into Earth and that seeded life on this planet. That's really fascinating. And because we could do it the other way. Maybe we ship stuff out and we could seed life forms in other areas. And I thought that was awesome to bring attention to that. And I think there are other theories as well that are worth consideration, but I think panspermia is having its day, and more and more people are becoming aware of it.
Thanks to people like George.
Totally.
George is kind of a guy like me, just a guy with a natural curiosity who is an excellent communicator. You guys know how charismatic that guy is. George, if you're watching, God bless you, buddy. You're doing a great job. We love it. Okay? Cosmic Summit. Boom. All right. But, George is Chandra Wickramasinghe's biggest fan, and I can understand why. Chandra has been doing work, publishing dozens of papers and dozens of books on his research with panspermia, this idea that, the universe, you can seed life with microbes throughout the universe. Microbes can survive the vacuum of space. They can survive harsh conditions. Why have they evolved to be able to do that? Well, panspermia offers us this answer, not to the origin of life, but to its distribution. So, George will be the first to recount the incredible story that Chandra was a part of a team of scientists who published a paper where year after year after year, they found microbes on the outside of the International Space Station. You guys might have heard of this story, okay? So, why are we not making a bigger deal about that? Credit goes to George for making a big deal about that. I mean, I learned that from him, and I'm sure a lot of people learned that from him. Why didn't we learn it from NASA or the other scientists? I don't know. I guess because they don't want to make a big deal about this. But Chandra found organic matter in deep space, the spectroscopic signature of E. coli bacteria in deep space. As we saw in the film, Chandra himself published a research paper that included photographs of diatom microfossils on the Polonnaruwa meteorite that fell to Earth in 2012. And we talked about the Allen Hills meteorite's the most well-known, but in my opinion, it's not the best example of it, because to this day, scientists still publish papers. Yes, it is. No, it isn't. Yes, it is. No, it isn't. I'm like, guys, there's other examples here.
Right.
And I remember sitting at Longhorn Steakhouse with Professor Richard Hoover, who, for those of you who don't know, was the lead astrobiologist at NASA's Marshall Space Flight Center. So when a lead astrobiologist from NASA says there's diatom microfossils in a rock, why are we not believing him? You know, that's very strange to me. It's like, well, what does NASA say? Well, it's NASA. Here it is. He published the paper he's photographed, and that's one of a dozen. I followed up with Professor Hoover, and I did a whole 5-hour interview with him. He's another guy who just has a lot to say. You know what I mean? The history of microfossils since 1961. So that blew my mind. It wasn't just the 80s they were publishing on this. It was as far back as the 60s that they were publishing about microfossils with photographs. I'm like, how come it took us until 1996 to realize this? There's a story here, you know, and that's why he says in the film, because I already knew. This is crazy. Everyone knows there's microfossils and meteorites. I'm like, really? What? What are you talking about? And
yeah, I thought it was interesting that it's okay. I think it's a scary idea for folks who, you know, you crack open a meteorite and there are fossilized microbes, basically, is what this is. But also it was mentioned in the documentary that, I forget who it's, but he said, okay, if that exists, well, if that then evolves and then that creates plants and then that creates animals, and if that then creates some higher level thinking species, you know, that's awesome. That's stacking a ton of ifs on top of itself. But you don't even have to go there. But just, it's okay if you don't think that's true. Just acknowledging that the basic form of life does exist elsewhere, off planet Earth, that by itself, you don't have to take further reaching if statements beyond that. It's still unbelievable. It would change our whole paradigm what we're looking for in planets and what we're doing.
It is. And I love what George says. He's a radical panspermist. It's an interesting name. I'll grant you that. But yes, when you will talk to people, astrobiologists, boy, I've talked to them, and a lot of them will say there is absolutely no evidence for panspermia. And I'm like, you haven't seen what I've seen. It's like, I can show you pictures. I can show you the research. And the reaction that most of them take is, I don't know that guy. It's not credible, or even worse, I don't even want to look at it. I've literally been in front of somebody showing them pictures and they are afraid to even look. It scares people. And I think it's odd. You know, the institutional Orthodox narrative can really restrict people, you know, if they're worried about their job. You know, I get that. We're all humans. We all want to, you know, keep our jobs, but, you know, it can be threatening to upend the established paradigm.
Do you think it's a little bit of old dogs kind of still in position? I think we're a little bit in, you know, I think we're deep into the information age. And so I think anybody younger than me grew up having tons of information thrown at them and being okay with that. And we're trying to figure out what's information, disinformation, misinformation. And that's kind of the challenge.
Yeah.
And I think Zuckerberg, he even says, like, more information is always better. In the situation, more information is always better. But I think, to your point, if there's old dogs still around and it was all about Cold War, information was to be harbored, then maybe they're just hanging on to these old paradigms that they just think, and it's okay. I get that they even think it's a good thing to hold on to that information and maybe not share it with anybody. Do you think that's a bit of it, or, you know, what's your thought?
Yeah, sure. I mean, imagine spending your whole life working on something. This is what my entire career is based on. And then ultimately you find out that most of it, if not all of it, was wrong. Then are you seen as an expert anymore? Like, do you get to keep your job? Do people want to talk to you? Because if you've been wrong the whole time, then you have to call into question your entire career. And that's hard. I get it. We're human. That's hard for people to do. I wonder who's going to prove some of the stuff in my film wrong. I'm like, am I going to be able to admit that? Like, you got to. I may not have got 100% right. Time will tell. And you know what? I'm not even making any conclusions. I'm just saying, here's the evidence. What does it look like to you guys? I know what it looks like to me. That's why I made the film. Like, and that's when I was, you know, getting back to Richard Hoover. I said, you know, Richard Hoover, you know, everyone talks about the Allen Hills meteorite being the most well-known meteorite, and it's because there was a photo of a little thing that looks like a little worm, and Bill Clinton's talking about it, but it's this photo, man. I will see that in my news feed once a year. Like, not some random website, but like a major news outlet. Scientists are talking about the Mars meteorite with the microfossil. Like, that's the one they're talking about. And they don't have any idea about the others. I said, Professor Hoover, if there only was a photograph of these things that you talk about. He goes, huh. And he whips out his tablet. And it's the things that I show you, the 2 full-length diatoms. I'm like, I don't know what a diatom is. Do you know what a diatom is?
Nope.
Okay. What's a diatom? I don't know what it is, but I know what that looks like, and that doesn't look like a rock to me. And then he whips out and he shows me the even closer in image with what looks like ribs. I'm like, that looks like biology. And just to the untrained eye, are we that ignorant? Are we that afraid of taking a look at something? So the common criticism of these things is that it's terrestrial contamination. Now, he's talking about nucleobases and amino acids and protein amino, whatever. The bottom line is there's a few characteristics that you can factor in that prove, and I don't say this word lightly. Side note, there's the word evidence, and then there's the word proof. I'm going to use the strict legal definition of the word evidence, which means suggestive of. Proof means conclusive of. Okay? People like to conflate those terms. Evidence, like it's the blood stain on the carpet. It's not, So, in a legal case. So when you have what appears to be, first his point, which is well taken, what Professor Hoover says, there's an animal, he makes an example. There's an animal, it looks like the cross between a deer and a zebra. It's called an okapi, okay? You may never have seen one of these things. It's probably in Africa, okay? I don't know. I saw a picture of it. I'm like, I've never seen one of these things before, but I know that's an animal. It's not a brick,
Right?
or it's not a rock, okay? I know that's life. And that's the same reaction that I had. I don't know about you guys. When I saw those diatom microfossils, I'm like, that's life. I've never seen that before. I don't know what it's called, but I know that's life. You know it when you see it. So, and as it turns out, there are more examples of this. And, I had to go back and interview him again because he just knows so much and he's been keeping track of this for a half century. Chandra has too. But aside from these 2 guys, I don't know who has. So if they unfortunately pass away, that knowledge is lost for a very long time until someone else comes up and wants to go through 50, 60 years of research. And so I'm just trying to do my best to capture it all for everyone else to understand.
This feeling that you're sort of displaying to me is sort of the sense that I got. Now, everyone on the film was very professional, and they're just explaining things that are very matter of fact. But I get this sense that they're almost a little incredulous, almost like I've been screaming this at the top of my lungs, like through research papers, for decades. Behind the scenes, did you sense that anybody was just frustrated? Like, for all the people that say, if it was out there, I would know, it's like they've been shouting it so that you can know, but we haven't been hearing. What was the emotions that you sensed from some of these guys?
Fortunately, none of them really seemed bitter. I think they were happy that here's this new guy who just wants to talk to them about their life's work. And, they had a smile on their face and they were more than happy to tell me everything, their entire life story. But to your point, yes, we get into it a little bit in my second interview with Professor Hoover, but, his research into these microfossils, directly led to his retirement at NASA because he started at NASA in 1966. And NASA in 1966 is a lot different. Back then they're like, shit, we're just making stuff up. Just like whatever you want. Let's just bankroll this whole thing and fuck it. We're just doing a whole bunch of experimentation. We're on the search and we're going to go out there in America. We're going to conquer the whole solar system, right? That's not NASA today. It's all very delicate and very ifs, maybes. We're going to search for signs, maybe, of ancient life by looking at the rocks. They don't really want to cut to the chase. So the NASA that Professor Hoover started with is not the same NASA that it ended up with. And he just got so frustrated with the culture. And I met a gentleman, another one of these really really smart scientists, who I was not aware of before I made the film, but I was fortunately able to connect with him after and have since interviewed him a few times. A gentleman by the name of Dr. Stephen Fenner, who's an award-winning biochemist, who knows the Viking life detection experiments inside and out. And there was 3 life detection experiments. There's only one that we talked about in the film. There's 3 of them. And he knows the details inside and out of these things better than anybody, okay? And despite whatever NASA says about there being absolutely no evidence that there's microbial life on Mars, their own results indicate otherwise. And he explains all of this. And I can do my best to paraphrase things. But, you know, you have these incredibly smart people who've been around for a while. They know exactly what they're talking about, and I can't find anybody. I went actively, like, can you tell me, where's he wrong? Where's he wrong? Where's he wrong? I tried to do that for here, there, and everywhere, and I'm not, that's not enough, man. It's not enough. But, you know, I've been fortunately blessed with the access that I've been able to get to these folks, and, you know, I forgot, I lost my train of thought. But anyway, these guys, you know, they really know their stuff, and you know, they're still with us, so they're more than happy to talk with me.
Well, and I noticed the resistance. What's the name of the place on Mars where the face is and the pyramid? What's that big region called?
They call it Cydonia.
Cydonia. And you would think with NASA releasing photos of Mars that we find this face, and maybe it's a face, maybe it's not, who knows? It seems compelling that it is, but we don't know. But there's a lot of cool stuff happening right there. And NASA being a publicly funded, you know, institution, you would think that when everybody says, go back there, go back there and let's do more digging. And they're like, no, there's nothing there. We're going to go to other places. It is just suspicious. Like, why go other places when you have no reason, when the public, everybody who cares about Mars is saying, go back to that place. Let's find out more info about that. Like it would actually make you popular. It would make people like NASA and not talk negatively about them as a drain on resources or something, to listen to the public and go back there and let's discover more. So it is a little suspicious to me that they would decline, still use resources and just go to different parts of the planet, even if the public wants them to do something else.
Oh, can I speculate on this?
Yeah.
So we just talked about how a lot of these scientists don't want to admit that there are microbes inside of asteroids. And NASA's excuse for why they don't want to go to Cydonia is because they don't want to contaminate it. Well, if you believed that Mars has already been bombarded with meteorites and asteroids and whatever, then you would assume there's already microbial life because it's already been hit. So that's why you can't say that there's microbes inside of asteroids, perhaps. I'm speculating here. This is just Austin speculating. But that kind of fits. I might have put a piece of the puzzle together there. Because that's like the gateway drug. It's like, oh, if we know that microbial life travels through this, we know that these things have hit Mars, which everyone thinks that it's been bombarded.
There's pockmarks.
Then we would assume we'd assume we're not going to contaminate it too much. It's already contaminated.
It lets the whole cat out of the bag that if microbial life can live inside of meteorites, then it's everywhere. Meteorites hit everything everywhere. So that should mean that, and it doesn't mean it's all going to live everywhere it goes, but over billions of years of that happening, there's a non-zero chance that there could be microbes there.
Right. And just to clarify, this is an important point. What I showed in the film are photographs of microfossils.
Sure.
Okay, so these things are not living. So that's the point I forgot to make before, is that the people who say, the skeptics, the debunkers who want to say that's just terrestrial contamination. The rock came down from the sky and a little critter jumped into it. Well, first of all, how does it get to the middle of the rock? Okay. He said you break open a fusion encrusted rock, one that's been burned on the outside. Okay. You break it open, you take a look, you find these things. Now, they're fossilized. There is no DNA or RNA that they can pick up. There's missing amino acids and nucleobases, the things that life requires, okay, to live. And more interestingly, there's a lack of nitrogen. There's a complete lack of nitrogen in these structures. Now, why is that important? Okay, every living thing has nitrogen in it. And when you die, slowly that nitrogen goes away, but it takes a really long time. So the fact that there's no nitrogen means that these things have been dead for thousands, if not millions of years. So that's why it's not terrestrial contamination. But let's talk about a living microbe. What are the chances a rock comes down from the sky and it's got something alive inside? actually, chances are pretty good because the rock can insulate what's inside, even coming through the atmosphere, or even heating up on the outside. It won't, if it's sufficiently large enough and it doesn't blow up, then it can actually, microbes can survive atmospheric entry, if they're embedded in a rock. So this is not something that's controversial. This is something that's accepted within, if it doesn't pass, like, I forget what the temperature is, but it is possible. And yes, as we know, meteorites are coming down to Earth almost on a daily basis. I think we get hundreds of pounds of meteorites from Mars each year, from what I remember. Don't quote me on that. But if we're getting a bunch of meteorites falling down on Earth, so is Mars.
Everyone is.
And what's the percentage that at least one of them has something living inside of it?
Well, I want to back you up there. Are you? I didn't know this. So you're saying sometimes we get meteorites from Mars, like something that was on Mars comes onto Earth?
That's one of the famous meteorites.
How do we know that, and how does that happen?
It's a good question. We suspect that a lot of these meteorites have just simply been floating around for a very long time. The Allen Hills meteorite, they've dated it, and I'm not exactly sure how they are able to date these things, but what's not in contention is the meteorite's age, which is billions of years old. So billions of years ago, maybe 3 billion years ago, maybe even 4 billion years ago, it's a really old rock. It was ejected from Mars. Now, what ejects something from a planet?
A collision, I would guess, or some sort of catastrophic
energy.
boom.
A lot of energy of some kind.
The most common example you might say is what killed the dinosaurs. We think a big rock came down. It's got that big crater down in the Mexican, South American area. Yucatan. Okay, yeah. It's going to fly some stuff out in outer space. A lot of it's going to come back down. Okay, but some of it's just going to keep going. It has enough escape velocity, right? Right. So whether it be, and you look at the surface of Mars, what it has all over it, craters. Okay, it's been, as Avi Loeb, Mars surface has been bombarded for a very long time, and he did the math at something like it has multiple kilotons of explosive energy per square mile or something, just because the surface of Mars has been destroyed by meteor impacts, arguably, as Robert Schoch and the Thunderbolts project have outlined, by electrical and plasma discharge. Electrical discharge. By the way, if you guys are interested in more about electrical discharge and all of this, there is a channel on YouTube that covers this specifically, and they do a remarkable job. I pulled a clip from their documentary, but boy, do they know their stuff, and they make an awfully compelling case that the universe is governed more by electromagnetism than we give it credit for. Long story short, though, we see electrical scarring in a variety of ways on Mars. And imagine a giant lightning bolt. Yes, we saw the parking lot there, but quite often what it does is a giant plasma or electrical discharge, it'll zap the ground and suck all the material straight up. It doesn't blow it out like a meteor impact would. It just sucks it straight up and kind of deposits it maybe on opposite sides of the planet. It's a tremendously awesome force, but it works differently than a typical meteor impact. So if anything like that ejected it from space, and things are just floating around in space for millions or billions of years just because it takes a while to sync up with Earth's orbit, that's basically what's happening.
Was that the channel where they recreated the scarring? You had a clip in there where there's the Grand Canyon of Mars, which is as big as the United States, and it has a certain shape to it, and it kind of looks like electrical discharges on the sides and whatever. And this channel recreated almost, it was unbelievable that they used electricity to kind of somehow create a smaller example of exactly that kind of shape.
There's, let's just say, a half dozen electrical scarring signatures. One of them is this weird Valles Marineris Grand Canyon of Mars looking shape. It's kind of got a twisty thing going on. Another way is we see these hexagonal craters. Another one is this Lichtenberg, this lightning bolt pattern. Okay, all very different from one another. Electricity can interact with matter in a variety of different ways and create such dramatically different types of scarring. Yes, the Thunderbolts channel has hundreds of videos talking about electrical scarring and electrical forces in the solar system, even talking about stars and such. It goes quite into depth about all this stuff. But electrical scarring on Earth, electrical scarring on Mars, and I have to say, it makes a whole lot of sense. It just makes intuitive sense what they're saying. And yes, all these electrical scarring that we see on the surface of Mars is reproducible in the lab. And that's not the only one that was reproduced. All of these are reproducible in the laboratory. And Mars and the moon and the other terrestrial moons in our solar system all show these same types of scarring. We don't see too much of it on Earth because we have these active tectonic processes that kind of, erase some of that stuff over time. But we can take a look at the Grand Canyon. I happen to think it looks a lot like a Lichtenberg pattern. If you ask modern day geologists how it was formed, they can't really tell you for sure because water doesn't flow uphill and doesn't flow out like that. Now, rivers, the river systems, the streams and river systems, they do have a very similar, what's called a dendritic pattern, tree-like. It's very similar to what a Lichtenberg pattern looks like, but it's not exactly the same. There are subtle differences which you can spot if you know what you're looking for.
Yeah, they did a fractal measure somewhere in there. And I have to say, for anyone that hasn't seen the documentary yet, and it comes out on Amazon August 22nd, I think, some of the photos of the hexagons I wasn't convinced by, but some of them I was. And you have to see them because it's like, that doesn't look like a meteor. I mean, there's no way. You can imagine what it looks like when a rock hits a big clump of sand and it creates, it blows stuff out and you have rims on the edges and stuff. But a hexagon, like how in the heck do you end up with a hexagon? Did you find any pushback around, like, is there another prosaic explanation for hexagonal craters?
I wish I found one. I learned of this through the Thunderbolts. I learned of this through Robert Schoch. Obviously knew about this. In fact, he's the one who pointed me to Thunderbolts in the first place. That's how I learned about all this. And I watched this they got a couple documentaries about electrical scarring on Mars specifically, like a whole, 80-minute thing about electrical scarring on Mars. And it goes into so much more detail. It provides even a plethora of images. I only put a handful in there because, there's only much you can fit into it. But they've got well-researched and well-cited examples in there, well-presented examples, photographic examples of a variety of different types of electrical scarring, hexagonal craters being one of them. It's a good question. Just intuitively, what makes a hexagon? That's such a weird, specific, symmetrical shape. We understand a circle because we can do that. We go outside on the beach, we just hit the sand, and that makes sense. But what makes something with straight sides? I don't know.
This idea that planets discharge and strike each other with lightning, like we've seen those metal balls in science classes where they zap each other if you're too close to each other. I'd never thought of the idea that planets might be able to shock each other. Was this how did you come across that idea? Like, where did that originate? That's so interesting.
Yeah, I mean, there's a whole field of study called the electric universe. Okay, and this is what the Thunderbolts channel really does a great job of researching and explaining. That the two founders, unfortunately, one of them passed away the month before I started production on my film, so I unfortunately was not able to get him, but he would have been able to explain all this in great detail. And the other one has major medical issues and is not really able to speak. So fortunately, I did sync up with two contributors to the Thunderbolts project, Ev Cochran with the dog, and Dr. Don Scott, who's an electrical engineer. He talked about plasma discharge. So those who understand how electricity works and, are experimentalists, that, there are people who experiment with electricity and discharge and how it affects the landscape. We do know that lightning can come down and create a crater, can create these patterns. But it really does sort of challenge you when you start to think, well, how can there be lightning bigger than the lightning that we know? But then you think, well, what's when you shock yourself on the door handle? That's really tiny. That's lightning, but just really tiny. And so when we talk about it being scalable, Robert Schoch says it can be on the microscopic scale. We can see it on the door handle. We can see it in the sky. Why stop there? Why is there a limit? Why should we presume that that's the limit? Because all it takes, what is a discharge? It's just two things of opposite charge getting close together. And yeah, we're humans. We're, on this tiny little scale. And, go America, we think we know everything. But the universe doesn't care about us. It has ways of interacting with itself that, are hard for us to believe because we don't see it on a daily basis.
Do you know what the pushback is on the electric universe? Like, why isn't it? Because I think I've read some critiques of it, but I don't recall them. And I know that as far as I can understand, there's gaps in both of like what conventional scientists, how they think our universe was created. It definitely leaves some questions unanswered that it seems like the electric universe answers. But I think there are some things in the electric universe that don't explain some things as well.
Have you looked into electric universe stuff?
Very briefly, not a big of a deep dive. But I like to look into something, and then I look into the proponents against it, and then I look into the rebuttals of those proponents, and then the rebuttals of those rebuttals, and you keep going until no one says anything.
Sure. The criticisms against the electric universe, I wish I could speak a little bit better on. However, I'll say this much. They have a different way of looking at the universe.
Right.
They have a different way of interpreting what we call gravity. Okay?
Which we still don't know it, by the way.
We have, what is gravity? Gravity is the word that we use to describe a theory of how we seeing things operate. Okay? But they are able to essentially, prove gravity just using a different way, I guess, using electromagnetism. And I got to say, they make an awfully compelling case. I just don't know enough about the subject to really say for sure whether or not that's really going on. When I arrived at Don Scott's house, the guy with the cowboy hat and the Arizona out there, and he was talking about electrical discharge. He holds the hypothesis that planets have charge and discharge. So, goodness, what was the question? Oh, electric field. Okay, so I show up to Don Scott's house, and before we even start the interview, we're just chatting. He's like, black holes are bullshit. I'm like, okay, well, listen, maybe they are. Maybe they are. But for most people, they understand black holes a certain way. So he's basically saying they don't exist. I'm like, all right, look, maybe there's something to it, but you got to get me there first.
Right.
Start with where I'm at right now and then deconstruct it step by step, which was basically how I felt the need to do the film. What do you know about Mars? Not much. Maybe not you guys. You guys know a little bit more. But like the average person on the street, they don't know much. So I got to start with where they're at. And that's the problem with scientists. They go right to 60 miles an hour. No. Let's ease into it. Because scientists are people too. You got to understand that they have emotions and biases and things like that. And you got to approach them with a soft touch sometimes. But yeah, so the criticisms against electric universe, if someone wants to take a stand and say black holes don't exist, all right, well, maybe they might say, that's crazy. I'm going to throw the whole thing out with it. So I'm not buying the black holes are bullshit yet, because I haven't looked into it that much, but all the electrical discharge that you can demonstrate in a lab, yeah, that makes sense. That's good for me.
Well, and something fishy seems to be going on anytime anybody mentions gravity. We've done a deep dive. We had an interview with Paul Shatskin, who was the biographer for Thomas Townsend Brown, and he did a lot of experiments around electrogravitics in the 30s, 40s, 50s that maybe got taken dark by the military-industrial complex. I think it's because, kind of we were talking about earlier, that the knowledge can be dangerous. If Einstein's correct, then gravity is linked to time. And so if you crack gravity and how it works, you can manipulate time. And that's we're getting into real serious stuff where I don't know if I want everybody on the street to have access to gravity machines if it manipulates time. I mean, I can see a world where you create a box and you throw a guy in and all of a sudden he comes back out and it's 1,000 years later because I just made a box and I want to be a bad guy about it.
Yeah.
Like, but every edgy kind of electric universe, everyone's trying to approach gravity because we really still, as far as I know, conventionally, we don't know what it is. But it does seem dangerous if we keep moving
And
towards that.
The electric universe crowd is fundamentally opposed to basically Einstein's general theory of relativity. So
Right.
if you're going after that, boy, you better
That's right.
got something to back that up with. You know what I mean? So, because that's pretty much like the gold standard. Everyone refers to his two theories. So, I like to go to bat where I can, but I got to back off when I don't know what I'm talking about.
Yeah,
Sure.
and it's out of most people's leagues. And I really liked how you interspersed in the documentary street interviews with people to see where they were at on certain topics. And you just kind of like lay a foundation of like, here's where humanity's kind of starting. But then you talk about was it called the Brookings Report?
Mhm.
Can you talk about what that is and what influence that may or may not have had over some of our policies?
The Brookings Institution, which is still around today, basically came up with a document that was crafted for NASA at NASA's inception in the early 60s. They put together a document, hey, NASA, you're going to go out and explore space, okay? So here are the things that we think you need to be aware of before you go out and find stuff, right? You might find some interesting things on the terrestrial bodies, Venus, the Moon, and Mars, artifacts. And if you do, you might want to think about how you communicate that to the public. Now, as Mark Carlotta says in the film, he thinks their intentions were good because you don't want to cause mass panic. But if you take that too far, then it starts to look like you're suppressing the information. And that's where Dr. Brandenburg, he's like, they told NASA if they found anything to spike it. So you could interpret that a few different ways, but Brandenburg calls this the founding charter of NASA, and Carlotto says, yeah, there's reason to believe that they're still implementing that playbook.
Who funds the Brookings Institute? Like, where does it come from? Where does it get any authority to give any opinions?
It's a consulting firm, I think. I don't know who funds it, but essentially you would go to somebody like Brookings to say, hey, advise us on something. So it's not policy. It's just more like recommendations. But it seems like NASA was taking them quite seriously, in my opinion.
And you think it's possible that advice that they gave NASA early on maybe is still in play?
Yeah. I mean, if we wanted to use the evidence for life on Mars, okay, so what we present in the film is NASA's Viking mission, which included the life detection experiment, okay? Now, this life detection experiment, I didn't get into all the details. There's only so much you could fit in a film. This life detection experiment, designed by Dr. Gil Levin, he designed this before he even met NASA. He was an engineer, a sanitary engineer, and he needed a test to see, does this water have any pathogens in it? I don't know. I'm a smart guy. I'm just going to make up a little gizmo and test it myself because I'm that smart and I can do that sort of thing. Okay? So he did that. And his test was so good that it was run over 4,000 times here on Earth, and it never produced a false positive nor false negative. I don't know what you call that, but to me that sounds like it's a perfect test. So, at a cocktail party one night, Gil Levin goes up to the national administrator. Hey, I heard you're going to Mars. You guys looking for life? I think I got just the thing for you. I got this little box. You got to put it up. You got to get it to Mars. But if you can get my box to Mars, it can tell you whether or not there's microbes there. And what does it do? It takes in a soil sample. It feeds it some nutrients, and then it just waits to see if any gas is produced. Okay? Living things we eat, we make gas. Okay?
Right.
We burp, et cetera, et cetera.
Entropy.
Okay? And guess what? They sent this thing to Mars on 2 different Viking landers, Viking 1 and Viking 2. 2 orbiters, 2 landers on opposite sides of the planet. These things land, they test the soil It's essentially measuring microbial metabolism, respiration. And on opposite sides of the planet, this thing on both sides of the planet tests positive.
This is in the 70s.
This is 1976. Okay? Now, the question is, why hasn't NASA said, like as Dr. Gil Levin says, why didn't we pop the champagne? We found it. Okay? Well, the problem was, and this is especially important to know, okay? And this is what a lot of people gloss over because they just accept what NASA says. NASA says there's no evidence for life on Mars, which is not true. The problem is NASA also sent another test over there at the same time on Viking. And this test was an organic test, an organics. It was going to sample the soil to see if there's any organic matter in the soil. And that test came back negative. So, to NASA's credit, they were confused about this. How do you have life in the soil with no organic matter? That's really strange. Now, here's the problem. The problem is that test, the organics test, wasn't good enough. It wasn't sensitive enough to detect the organic matter it was looking for. They tested these things in Antarctica before they sent them to Mars, okay? Gil Levin's labeled release experiment found microbes. This organics test did not find any organic matter in the soil of Antarctica. So they knew that they kind of had a faulty test before they even sent it to Mars.
In Antarctica, it tested negative, no organic compounds.
And there's organic matter in the soil in Antarctica. Of course. Now, what makes the matter even worse is that the narrative since 1976, up until quite relatively recently, was that there's no organic matter on Mars, thus no life. So Gil's test must be wrong. The Curiosity rover, which most Americans are familiar with, well, guess what? That found the organic matter. And scientists are like, oh, look at that. There's organic matter in the soil of Mars. How about that? It's been there the whole time. Now, did NASA revisit the results of Viking since then, since discovering the organics from the Curiosity rover? No, they haven't. You have to question why. Well, maybe they just don't want to be embarrassed by it. They were already embarrassed once because they hyped the public up in the 70s. Hey, we're going to Mars. We're going to look for life. We got the life detection. But, oh, wait, it kind of came back inconclusive. So we're not really sure. So that was kind of an embarrassment for them. But then to go back and to admit, oh, we made a mistake in 1976. Okay. Now, the Curiosity rover, it tested and it found this organic matter in the soil. And it also found something else. It found an organic substance. This is what I learned from Barry DiGregorio. Actually, I learned this from Richard Hoover. I learned a lot more after the film was made from these two gentlemen, from everybody, actually. The Curiosity rover found a specific type of an organic substance known as dimethyl sulfide. Okay, it's a mouthful. Dimethyl sulfide, what the hell is that, right? Well, here's what you got to know. Dimethyl sulfide, the only way scientists know that it is produced is through active microbial life. NASA, on their website today, says this. We only know one way of producing dimethyl sulfide, and that's through microbes. We don't know any other way to do that. You guys know the James Webb Space Telescope?
Yeah.
It's looking at all these distant galaxies and finding really cool stuff. You know, maybe just a few months ago, we found exoplanets with atmospheres that we believe to be habitable. Right. That says well, there's signs of life in these atmospheres of exoplanets. You know what causes them? What prompts scientists to make that claim? What are they looking for?
It's got to be the gases in the atmosphere. I would guess.
Dimethyl sulfide.
They're looking for dimethyl sulfide. That's what they base that claim off of. So they find dimethyl sulfide in these exoplanets light years away from us. And I'm thinking, that's great. Okay, Han Solo, you go there, tell us what it's like in a million years. But we got Mars right next door.
Testing positive. It's in it.
Curiosity rover's finding dimethyl sulfide in the surface. Why are we not making a bigger deal about that? Okay? So when we talk about the evidence for microbial life, guess what? It doesn't stop there. Dr. Carol Stoker, who works for NASA, this amazes. This is like irony or something. Like, how do you work for NASA and not have this information? NASA's great at finding stuff. They just don't talk about it. Nor back their own scientists up when they find something interesting, okay? Dr. Carol Stoker works for NASA to this day. She found, through the use of spectroscopy, you guys know what that is?
Yep. You shoot it with light and then it registers different wavelengths or something.
Boom.
Yeah.
Okay, through the use of spectroscopy, she found chlorophyll.
On Mars?
Mm-hmm.
No way.
Like recently?
Yep. And there's one more thing. And this is where I got to credit my friend Barry DiGregorio, too. If it weren't for these researchers, I would know none of this stuff. I'm just a communicator. Okay? There's another funky thing on Mars, something called rock varnish. You guys heard of rock varnish?
No.
Neither have I. Okay? Most people don't know about it unless you're a microbiologist who studies, things like bacteria and bacteria colonies and slime for a living. But if you go out in the middle of the desert here in America, you'll find on some rocks there's this black coating, okay? And they call it looks kind of shiny, like a varnish. They call it rock varnish. Sometimes they call it desert varnish because you find it on desert rocks. This black coating, over hundreds or even thousands of years, is essentially created layer upon layer by certain types of bacteria interacting or even digesting manganese, something like that. It's a bacterial product. It is produced by active living microbes. Guess what? They've photographed rocks that look exactly like that on Mars. There are published research papers by people at Nina Lanza at Los Alamos. I think she's at Los Alamos. But people, scientists who are officially affiliated with NASA, publishing papers on this rock varnish they find on Mars. And they say, we're trying to find a mechanism that explains the creation of this rock varnish because it can't possibly be microbes. It's got to be something else that we're unaware of. What kind of sense does that make? It's black coating. It's not exciting. But to say there's absolutely no evidence is legally false.
Man, that's wild. A lot of people, I think, believe nowadays that Mars may have experienced like nuclear explosions. I want to ask you if people watch your documentary, will they be disappointed to find out that there were no nuclear explosions?
When I first started weighing whether or not I should make this documentary, I'm like, okay, there's the face on Mars and there's some other interesting anomalies on the surface and maybe the Viking stuff. It's not quite enough for me to get into the game. Then I came across the work of John Brandenburg, and this is what you're talking about, and I read his book. And I'm like, this is terrifying. Kept me up for a few nights. I'm like, all right, you know what? I'm going to email this guy. If he emails me back, I'm doing it. If I never hear back, well, that's fine. I'll just leave it alone. So New Year's Day, 2023, Brandenburg emails me back. He said, I'd love to get together with you to do this documentary. I'm like, shit, okay, I guess I'm doing it now. Because this is a bold claim. This is...
It's ridiculous.
It's ridiculous.
It's ridiculous.
It is. Okay, so I had to vet this, of course, and I had to go through all the research and yada, yada, yada. So what compelled me to go to bat for this? Bat for the research, bat for the guy who's been marginalized his entire life. No one else is talking about this. And it just gets down to the data. The data speaks for itself. So, I mean, this is really jumping into the deep end here. So, let's just examine these things. Xenon 129, this gas, this isotope of xenon, right? If you go to Wikipedia right now, it says there's two ways of producing this. Okay, supernova explosion or inside of a thermonuclear weapon. Okay, so let's just examine. Did a supernova place a bunch of xenon 129 on Mars? Well, let's see. If there was a star close enough to explode to our solar system, it probably would have blown our solar system up. But if it didn't blow our solar system up, it would have placed an equal amount of xenon 129 everywhere else on the solar system, on Earth, in the solar wind, and the meteorites.
All right. A blast would have blasted everything.
Yeah.
And we would see a consistent coating,
Right.
if you will, of xenon 129.
Not just Mars. And it's the proportion of xenon 129 to xenon-132. Okay, the relative proportion between the two, there's this spike, okay, of xenon-129 only on Mars. And that same spike, and you could line it up like this on a chart, which Brandenburg has done, that same spike, you can measure it every time they do a nuclear weapons test, an atmospheric nuclear weapons test. On Earth, it's that same spike. Okay, there's people's jobs who there are people whose job it is to observe the Earth atmosphere for any unauthorized nuclear tests. And you know what they're looking for? That spike. Okay, so that was the first thing. The soil itself is radioactive. We know things like Chernobyl. Don't go there, okay? Because it's radioactive. You're going to get radiation sickness, all right? The soil itself is radioactive on 3 spots on Mars.
Concentrated.
Yes,
Yeah.
as if, well,
As a bunch got put in 3 specific spots.
concentrated. That's right.
Yeah.
Yet there are no craters. Okay, but if you look at World War II, what do you see in Japan? 2 atomic explosions, air bursts. There's no craters in Japan, Hiroshima and Nagasaki. Okay, and these 2 spots on Mars are locations of what appear to be ancient shorelines. Okay, populated areas. One could say on Earth, where our shorelines are populated. Okay, on the very opposite side of the planet is another one. So if you just trace around equally, these things would meet on the opposite side of the planet, colliding with themselves and producing another hotspot. The soil itself in these hotspots is radioactive. And, you know, Brandenburg goes into great detail to explain the different types of radioactivity, thorium and things of this nature. I don't know it well enough to explain it. So, and at these spots, the surface is also littered with natural glass.
And it's close to the face and some of the pyramids and things. So right? So theoretically it could be where a civilization was.
Right.
If you want,
take those steps, then
right.
yes.
If that could be a civilization, that would be where you would maybe detonate one. If there was a
Yes.
war or some sort of attack or
Yes.
whatever that means.
Right.
It's kind of near all the other weird stuff.
So there's one more piece to this, okay? What's important to know though is that so I wanted to check this out. NASA, what can you tell me about this? Nothing? Okay. JPL, nothing. Lawrence Livermore. Lawrence Livermore is where they build fusion reactors. Okay, it's the place to go. It's like if you're a nuclear expert, you're in America, you're most likely at Lawrence Livermore. Okay, that's where Brandenburg went. Okay, they didn't want to talk about this. I'm like, okay, who am I going to get to talk about that? I need somebody to get to talk about this. So I approached this professor from Georgia Tech who's a nuclear weapons expert. I'm like, hey, have you heard about this Xenon-129 on Mars? I did get him to email me back. He's like, yeah, I've heard of that Xenon-129, but don't worry, that can be explained by natural processes. And he gave me an example of, to my surprise, there is an example here on Earth of a natural nuclear process that happened a few million years ago. In the African country of Gabon, there's a uranium mine. Okay, and a few million years ago, water seeped into this mine. And long story short, it actually caused a chain reaction to start a natural nuclear process. I don't know why uranium and water do that, but they do. Okay? It did not create an explosion. It sort of kind of fizzled out, but it did create a nuclear reaction.
Smoldered.
Something like that, yeah, more or less. And they can. This is not in contention. This is known science. So this is the example, the only example scientists can point to, saying, "Hey, look, there's a natural nuclear reaction. It happened here on Earth. It can happen." Now here's the problem. Okay, the problem, generally speaking, is that not all nuclear reactions are created equal. That type of nuclear reaction does not create the spike of Xenon-129. The type of nuclear reaction that we do in our nuclear power plants does not create that Xenon-129. We talked about our process in the film, okay? There's S process and R process. Nuclear power plants and this natural nuclear reaction in the African country of Gabon and the uranium mine produced S process nuclear process. Okay, what does S mean? S stands for slow. It describes how fast the neutrons are being absorbed into the nuclei, which creates the nuclear reaction. Okay, slow. It's a slow-moving neutron. S process.
Smolder, baby.
That's not S for smolder. But that's not what we see on Mars. We see evidence of our process. Fast-moving neutrons. There is a distinct signature difference. So, am I ready to go to bat for this? Yes, because I can't find anybody, nuclear weapons experts, to refute this. If that's the best they got, they can't explain it. And that's frightening to me.
It should be.
And it's billions of years old? Millions of years old? What's the estimate on that? Do we know?
The latest Brandenburg told me was maybe 1 to 200 million years ago is when he thinks that happened. Now, here's one more interesting thing that connects both Brandenburg's research and the electrical universe, the plasma discharge. These people are so smart. They got this archival memory of everything. So you just soak it up as a sponge, okay? Just learn everything you can from these people, okay? Because you've got to pass it down to the next generation. During the mid-20th century, we did these atmospheric nuclear weapons tests, okay? And there's film footage of this stuff, right? There's at least one piece of footage that I am familiar with that I've seen with my own two eyes of an atmospheric nuclear weapons test that creates lightning.
Whoa. All right.
That could explain some of the scarring on the surface of Mars.
And I think they said that it was like 50,000 times bigger than the Hiroshima bomb or something.
He said it was
50,000 times bigger.
He said anywhere between 10 and 100 times more powerful than the impact that killed the dinosaurs.
That's right. Yeah.
But yeah, it's probably 50,000 times bigger than.
I remember it was megatons instead of kilotons. Or I remember it was a lot.
Something, yes.
2 orders of magnitude at least larger. Yeah.
Yeah, lots of joules of energy. It's incredible to completely. He did the math, and basically, if you were to put all of the nuclear weapons in one spot, it would equal the size of the Empire State Building. That's how much energy would be required to blast away a planet's atmosphere. You guys see Oppenheimer?
Yeah.
Is this really so far-fetched? Do you remember the scene between Oppenheimer, Cillian Murphy, and Matt Damon? Before they run the test, Matt Damon comes in. He's like, what are the chances that we ignite the atmosphere and destroy all life on Earth? And Cillian Murphy's like, oh, there's a near zero chance. Near zero. The near zero part. This is what they were afraid of. Atmospheric ignition. Now, our nuclear tests here on Earth were not sufficiently powerful to ignite our atmosphere. But you get a whole lot more weapons, say an Empire State's Building worth, that
might do it.
Man, that's wild. I wanted to ask, you didn't get a chance to touch on any of this, and I don't know if you know anything about the moons of Mars. Have you, across your research, come across anything? I don't know anything about them, but I saw there's 2 moons. Is there anything going on with the moons up there?
Yeah, probably not as juicy as you might think, but or you might hope. But I can tell you 2 things with Mars moons. They're tiny. 3 things. Number 1, they're tiny. They're not like our moon, right? They're pretty tiny. They're glorified asteroids, really. So why are they so tiny? Well, if you think about it, if you think about how many impacts Mars has had, meteor impacts for plasma discharge, shit getting thrown up in the air, well, some of it's going to come back down and land, some of it's going to go to Earth, and some of it's just going to start orbiting around the planet. Mm-hmm. So there's good reason to suspect that it's just part of Mars that just got stuck in orbit after being blasted out of space from an impact. And what's interesting to know that the Thunderbolts cover is that on one end of, I think, Phobos, which is the larger one, it's got a huge crater in it. Okay? A crater so big that had it been created by an impact, it would have blown up the whole thing. So it makes you think, well, if it wasn't an impact, it must have been electrical plasma or discharge that carved it out. because it's not an impact. It's really just an electrical process interacting with the matter and excavating it, but it would not destroy the surrounding area. This is why we don't see, these debris fields around these craters. It's just the hexagon. There's no debris field around it because it wasn't an impact. It's different mechanics altogether.
Is another explanation could be that the moons were a part of Mars at some point in time, and they got hit with a bunch of these things, and then the big explosion happened and knocked it out into orbit. So it's an older crater maybe on the moon that happened pre it being a moon, and kind of maybe it's a part of, but maybe we know if that moon would be a part of Mars. Maybe we'd find the puzzle piece and be like, oh, there's the crater it would go in or something.
It's possible, sure. It's most likely it's just part of Mars. No, I don't know how it got there.
Yeah, right.
But it's just an interesting thing. The Thunderbolts do a really great job of looking at all these scarrings, all these scars across the terrestrial bodies in our solar system, even the outer moons of Saturn and Jupiter. They've got some amazing scarring on there too. But yeah, of course, it's possible.
When you mentioned earlier, I don't want to bypass this because you said it briefly, but you said there's glass on Mars, some sort of glass. Is that what's the deal with that?
Yeah, when soil or sand gets superheated, when lightning strikes the beach, it creates a type of natural glass. When you do a nuclear weapons test, the Trinity nuclear weapons test, they've nicknamed this natural glass trinitite. So he just refers to it as trinitite. There's a trinitite-like natural glass on the surface of Mars in these hotspots. Now you start adding all this stuff up, and I'm like, okay, it requires superheating. Yeah. Electrical discharge could superheat that. We know lightning bolts can create that too, of course. So whether it was created by that or something else, but I don't know. That scar on Mars, the Valles Marineris, is the size of the United States. What causes that? I mean, if you imagine that was a giant lightning bolt, whether from the sun or whether from a different planet that excavated all of that material, I mean, it would have gone everywhere. That's why you look at these rover photographs. What do you see? You just see these rugged rocks everywhere. It's not the polished rock that you might find at the bottom of a riverbed, that's been wet, eroded over time and nice and smooth. It's just all jagged stuff like that. That's violence, man.
It's like the Guts trophy from when I was watching Guts as a kid. Remember the aggro crag? Sorry, obscure reference.
Was there anyone you thought you'd be able to get to comment on this? Like maybe a detractor that you were surprised? Any organizations that they just wouldn't come forward and participate in the documentary?
I did approach. Well, okay, so besides NASA and JPL and these institutions that we talked about, because I wanted to go to NASA and not just talk about Brandenburg's work, but everything, even just the stuff that they could most likely handle. Like, this is softball, guys, here, okay? Just I want to talk about Viking. You can guys talk about Viking, okay? They didn't want to talk about nothing. But I did approach other academics, okay? I approached another academic, and I sent him the picture of the crinoid fossil, right? And, God, he was so reluctant, and he was just kind of a bit short with his response, just telling me that it's a crazy idea. So you do have one paleontologist saying this is crazy, this is nuts. Oh, and that's what prompted the question, because he said it's not differentiated from the matrix, meaning it's not separate from the surrounding rock. And so I said, what do you make of scientists saying it's not differentiated from the matrix? And Hoover's like, yes, it is, and here's why. So I really need these experts to get together and talk, but they're so reluctant to do that. They're just siloed. Yeah,
there's no upside.
Right, I know. And there's someone in the film, I won't say who, that I interviewed who was not happy. After he interviewed, he changed his mind and didn't want to be a part of this anymore. Because I started asking him some other types of questions, like, wait a second, what kind of documentary are you making here? So there's a lot of reluctance, a lot of hesitation from academia and from NASA and its affiliated institutions, for sure.
I was surprised when I first met you that you weren't more into conspiracies, to be honest. I mean, people that have watched our channel, they know that Matt and I are open to everything.
Love hot takes.
We love hot takes. We're in the business of it, I guess. Getting clicks on YouTube seems to be what we're doing.
Well, I love them too.
Yeah,
right.
Yeah, they're so fun. It's just so fun to entertain stuff. But when I met you, you just weren't just talking about aliens and 0 point energy and anti-gravitics and things like that. It seems that you didn't even start into the fringe topics until relatively recently.
Yeah, that's right. I mean, I have my journey just like everybody else. In fact, I have a screenplay that I wrote 10 years ago that was my attempt at trying to write. I love film, love movies. Can you guys tell? It was my attempt to try to create a story, a very realistic depiction of what first contact would look like. So imagine the movie 2001 mixed with Contact with Jodie Foster. Okay, I wanted to mix the two of those. You get a little bit of space travel and adventure, but I wanted to show what realistic space travel looked like, and I want to show what realistic first contact might look like. And this was all done under the, my position at the time that I wrote it was that there's absolutely no evidence for aliens. For an alien species to travel to Earth would be too prohibitive because rocketry, it would take, so long to get from one star to another. It would take us thousands of years just to get to Alpha Centauri. So there's no way aliens have ever lived here. So yes, I was very much rooted in the traditional Orthodox narrative because, hey, I listen to NASA and I listen to our institutions and such. So yeah, making that change over after Ginger gave me Graham Hancock's book, and after she gave me Avi Loeb's book, I'm like, there's something to this. And then once I started reading more about Graham Hancock and finding his Mars stuff, it's a slow process, and to expect someone to change just at the snap of a finger is too hard. So yeah, I do come from that. But what it allowed me to do is to understand that there's a lot of other people out there like me who are going to be really reluctant to this. So I have to figure out how to message to them, reflecting on my own journey and giving them the time they need, first meeting them where they are, giving them a little bit of information at a time and giving them the time they need to have it soak all in, because paradigm shifts are tough, man. Personal, and beyond. It's tough. You got to, since we've converted, okay, now we were entertaining a whole lot more these days, right? I'm willing to listen to all that stuff you just mentioned, and there might be something to it. I've only got so much time in the day, so maybe I don't get into it myself and I don't bring it up just because I can't speak as an authority on this. But since I've done my deep dive on Mars, well, I feel like I got a little bit of knowledge there that I can, have a conversation with the layperson and the experts.
Well, where do you feel after, you've been involved in this for a long time, where do you think humanity's at? Do you think humanity's ready for some sort of disclosure that we're not alone?
You and I and people like us, we're pushing for that. We want to know what the heck's going on. We're curious, and we realize that it has the potential to profoundly impact us in ways that we never could have imagined. But at the same time, it can be scary. I mean, heck, in the middle of the night when I got to get up to go to the bathroom and I'm all alone here in my house, I'm saying to myself, I don't want to get sucked up into a flying saucer right now in my underwear. I'm not ready for that. So if you take a look at the spectrum of people, there are some people who are unaware of any of this, and we got to be gentle with them. They got to get up to speed, but there's going to be some people who just aren't ready to hear about this stuff, and we can't force it down their throats too quickly because then we seem like nutcases. But yes, I mean, you have to factor in how this is going to affect everything, institutions, religion, society. That level of change, if you're handling this responsibly, which I really hope we do, should happen gradually. The good news is that it finally seems like our culture is ready for that. We've started that. It's not going to happen next year, even though Chris Bledsoe might think it does. I have my doubts. Of course, what do I know? I'm just a guy, right? But if we're starting to have these conversations now, this is no longer crazy to talk about flying saucers. I was interviewing Avi Loeb again just a couple of months ago, and I'm holding up a little saucer. I'm like, we've got these things flying around in the air. And he's basically agreeing. Here you have a Harvard professor.
He's at Harvard.
Agreeing with me on this. He's doing the research on this. He's looking for aliens in the sky. We're in a different age now. you know, but it's not going to happen overnight. So we have to be patient. It's coming. To say that there's nothing to see here, now that starts to seem like crazy.
Well, and thanks for making the documentary, because it's things like that, like you said, communicating it to everybody in approachable ways. And like you said, going to where they are to start, and then start there, and then start unloading and showing things. That is probably the best way we can help, is to start educating in that way.
Yeah, and let's just take a look at the other stuff in the documentary that we haven't talked about too much, but you know, people are not too afraid of microbes on Mars. Oh, isn't that interesting? How about that? I knew that, you know, people might say that's not going to scare people. I don't think, okay, let me say this. I think that has less of a chance of scaring people. When you start talking about pyramids,
Well, that one thing you had that was metal with looked like a barrel coming out of it.
right?
That one.
Or artifacts.
Artifacts.
Or the tires. There's some
The tires.
There's some wheels.
Yeah, wheels.
Yeah,
like
wheels.
machine artifacts.
Yeah.
Or giant pyramidal structures with symmetry to them. Well, I don't know about you guys, but that conjured up a whole lot of unsettling feelings here. I was like, pyramids on Mars.
Yeah.
And it's a dead planet. Oh, God.
And it's 100 to 200 million years ago.
Well, that's what
Possibly.
Brandenburg says.
Possibly.
You know, well, okay. That's when he says the explosion happened. But, you know, I'll interview scientists. The science now shows that Mars was Earth-like, maybe even 1 billion years before Earth. That's a long-ass time, okay? So if it gave rise to life, even intelligent life, who built these structures, and then the atmosphere vanished, I mean, these things have been just sitting there for not just thousands, at least millions, maybe even billions of years. So when you see these structures that aren't pristine, well, what do you expect? What would our pyramids here don't look pristine, and we only date them back, you know, 10,000 years, maybe.
It's debatable.
You know, right? It's debatable.
But yes.
But
Point stands.
whether we'll have that effect on something. So I'm okay with it not looking precise, because it probably has a few million years of sand deposited on top of it. Now, Mars doesn't have much of an atmosphere, but has just enough of an atmosphere to blow around dust and sand, okay, which is enough to round off corners here and there. But if these things are truly pyramids, I don't know, man, that just unsettles me. Like, somebody built those and they're not there anymore.
Yeah.
We don't even know who built our pyramids, right?
And a lot of people think that NASA's been doctoring photos, and I think it's because they came out and said they've been doctoring photos. It's probably, I mean, they
probably why
talk
people
about
think that.
they talk about redshift and things like that. What's the extent to which you can trust NASA photos? What are they good for, and what are they not good for, and how have they been changed?
You know, NASA photographs. NASA has released millions, perhaps, of photographs, you know, throughout the past half century. There's enough anomalies that slip through that they're not catching, and I'm not going to say they're photoshopping stuff out. I don't have any evidence of that. Sure, I've heard people make that claim. I'm not making that claim. I think they're just taking the photos and putting them out there, not saying anything about it, and there's been enough that has been published that we have seen that we rightfully call attention to. Where I will say, well, I will agree and admit, is that they have doctored color, okay? For the longest time, Mars was red, the sky was red, everything was red. Doesn't matter. And we have learned that that's not true, and they have come out and said, yeah, sorry, we didn't want to make a big deal about it, but that's, you know, we kind of were doing that. If you look at Mars today, the sky actually, depending on the time of day, has a bluish or maybe even purplish, sometimes a little reddish, but hey, our sky looks a little red when the sun's setting, right? So it has a sky kind of like ours. It changes color throughout the day depending on lighting conditions and such. But that they were artificially changing everything to red, yeah, that's dishonest. And the question becomes why? Why were they doing that? Well, if their intent was to minimize any interest in Mars, saying, look, this is just a dead planet, pay no attention to this, that's going to go a long way of doing that. Because if we start seeing blue skies, we think, hey, that looks like home.
They othered Mars. It's othered. It's not like us.
Right.
Yeah.
Yeah.
I think that's a cool place to wrap up.
Yeah. What a great documentary.
Blue Planet Red.
Yeah, and let me just quickly mention two guys here. Jean Ward from South Africa, who's one of these fantastic independent Mars researchers, sifts through thousands of images, spends his spare time finding all sorts of anomalies. He's got his own YouTube channel. I've interviewed him for mine. Unfortunately, I didn't know about him before, or I wasn't able to get him for my film, but I've since, connected with him afterwards. Gary, the redheaded guy,
Yeah.
he's finding, I showed you a few of the triangles, okay? He's found dozens of these things. I don't know what makes those things. What looks like a tetrahedral pyramid with a line underneath that's a 3/4 mile line. What geological process makes that in multiple places?
Over and
I don't
over.
know. That's crazy. So these two guys are spending their spare time finding this stuff for the rest of us to enjoy, And these guys need to be commended. They need their work to be seen, and most people don't know them. There's another guy, Rami Bar Alan, who found that what appears to be column buried in the rugged landscape. We have this smooth column. It's circular and it's smooth, and everything else is rugged and jagged. He's in Israel, and nobody knows about him except for the Mars community. So I'm hoping to really highlight this independent Mars community. George Haas is another one. So I just wanted to give a shout out to you guys. You guys are awesome. Keep doing what you're doing.
Yeah. Props. Thanks,
Yeah,
everybody.
That's awesome.
It's amazing that NASA will just put it out and they're kind of like, hey, go find it. And some of these guys have taken the initiative to go find out what we're missing.
Well,
Yeah.
and are you continuing to document somewhere online where people can find it post-documentary, the things that you've been learning?
Yes. So you can go to the website, blueplanetred.net. It's basically the one-stop shop. It's got everything on there. The film's coming out in August, so it's a couple months away. I recommend starting with the film first, okay, and then going on to the series or the YouTube channel. Just my name, Brian Cory Dobbs, at Brian Cory Dobbs on YouTube. But the YouTube channel is really now set up as the continuation of what you just saw of the film. It's the follow-up, the sequel. It's just I'm doing it episodically now because there's so much more information, and I wanted to elaborate on some of the things that I did in the film. So, start with the film, move to the YouTube series. I post on Twitter every now and then, but it's really I'm trying my best. I favor quality over quantity, so I'm not pumping out stuff that much. It's going to take me 2 or 3 months to get something done because Mars has a lot of baggage with it. Nobody wants to take it seriously, so I'm really trying to elevate the material and the people working on it. So I need to take my time doing that.
Man, I really appreciate the work that you've been doing.
Oh,
it
thanks, man.
was really a joy to watch your
Thanks,
work.
man. Yeah, dude, it was so fun having you guys over.
Yeah.
Watching the movie with some new
this
friends.
was awesome. We watched it in Brian's living room on his huge projector screen TV with sound everywhere, and it was the best way to watch it. So thanks for having us over.
Yeah, man. I'm glad we could get together. So.
Right on. Cool.
Cheers.
Thanks, everybody. See ya.